All right, so now we're going to move on to the second section in this unit, which is on triangles and quadrilaterals. Now, I feel like most of you will probably have seen a little bit of this information before, just maybe presented in a different way. So just mainly with this section, make sure you're taking good, solid notes and you're following along, and I think the sections won't be too bad. So the first part is that there are two types of groupings for triangles. The first grouping has isosceles, scalene, and equilateral. Isosceles has two equal angles. And when we say the word angles for these, it also means sides. So two equal angles or two equal sides would be an isosceles triangle. Scalene, by definition, has zero equal angles, meaning every angle is different. And then equilateral, you should hopefully know, has three equal angles or sides. So that is the first grouping, which means that a triangle will always be one of those three and one of these three down here on the bottom. So an acute triangle means all angles are less than 90 degrees. An obtuse triangle then has one angle over 90 degrees. And a right triangle has one angle equal to 90 degrees. Now, for a piece of candy tomorrow, you have to tell me why these say one angle. Why can an obtuse only have one angle over 90 degrees? Why not two or three? And then why can't a right triangle have more than one angle equal to 90 degrees? So that is worth 2 pieces of candy, if you can explain that to me tomorrow. Now, for each of these, you can only have one grouping from the top and one grouping from the bottom. So a triangle cannot be isosceles and equilateral at the same time. But a triangle could be isosceles and acute. A triangle could be scalene and right, but it cannot be right and obtuse at the same time. So when we're thinking about things, you'll have one from here and one from here. So a triangle should always have 2 words to describe it. So for each of these triangles, the first thing we have to do is make sure we fill out the third angle. So I know the sum of all of the angles of a triangle is 180 degrees. Therefore, this angle has to be 60 degrees. Therefore, I notice that is 1, 2, 3 equilateral triangle. But every angle is less than 90 degrees. Therefore, it is also acute. So it's got 2 words describing it. Now, this little box here means equal to 90 degrees. Therefore, 90, 45, that means this has to be 45 degrees because they have to add up to 180 degrees. Now, I notice this has a right angle in it, so this is a right triangle. I also notice that these 2 angles are equal to lateral, so this is isosceles. Now, I'll tell you this now, and you're going to hate me for it, but if any of these words are spelled incorrectly, you will get the problem wrong. So make sure you have them written down in your notes. Now, number 3 down here, we have 123 and 23 is going to be 146. So I have to go 180 minus 146. So I got to borrow. So 34 degrees here. So this is obtuse, because 123 is bigger, and none of the angles are equal to each other, so it is scalene. And this is 47, therefore this has to be 43 degrees to make sure this equals 180. So this is right, because the right angle, and none are equal to each other, so it is also scalene. I want you to try these on your own. This one is right and scalene. This is right and isosceles. This is 70, 180, so this is 40. So this is acute and scalene. This is 20. So it is obtuse and isosceles. If you have questions, make sure you ask me. How are we doing on time? Oh, not bad. So for this, we got to take notes. We got to explain what it means. So the idea is everything inside a quadrilateral is either a kite, trapezoid, or parallelogram. And these are defined as such. A kite, let me pause it real fast here. A kite has two adjacent, that means next to, adjacent congruent sides. So a kite would have to look like this, where these two sides are equal to each other, and these two sides are equal to each other. So it looks like a kite that you'd be flying in the air. Okay? Now, more likely, you're going to see a trapezoid or a parallelogram. A trapezoid has one pair of parallel sides. One pair of parallel sides, where a parallelogram has two pairs of parallel sides. And I'm hoping you're asking that if it doesn't have a pair of parallel sides, well, then it's most likely going to be a kite. Okay, so when you have a parallelogram, it can get more specific than that. If you have a parallelogram with all 90-degree angles, then it's going to be a rectangle. And if you have a rectangle, it has to be a parallelogram. And all parallelograms have to be quadrilateral, so it moves up the chart like that. A rhombus, by definition, has all equal sides. All rhombuses, by definition, have to be a parallelogram. And all parallelograms have to be a quadrilateral, just like that. Now, a square is going to be both a rectangle and a rhombus and a parallelogram. So a square has all 90-degree angles, all equal sides, and two pairs of parallel sides. So you move up the chart like that. So if you have a square, it's going to be a rectangle and a rhombus, a parallelogram, and a quadrilateral. But a kite will only also be a quadrilateral like that. Let me show you an example of what we're talking about. So for this shape up here, I see that this side and this side are parallel. Also, this side and this side will be parallel. Therefore, this is a parallelogram. But if we notice on our chart, a parallelogram is also a quadrilateral. This shape here, I notice that this side and this side are parallel, but these two on the outside are not. Therefore, this is a trapezoid. But trapezoids are also quadrilaterals. Here, I notice that these are parallel, but it looks like every side is also equal to each other. Therefore, this is a rhombus. But I know a rhombus is also a parallelogram. And I know all parallelograms are also quadrilaterals. And finally, this side here, I have all the sides equal, and they're all 90-degree angles. And therefore, this is a square. Squares are also rhombuses and parallelograms. But it's also a rectangle, which is also a parallelogram. And finally, all of these things are going to be quadrilaterals. So as long as you use that chart and you work your way up, you should be okay. Make sure you ask me, though, when you're working on these problems. We'll do some more examples. Finally, the last one here is just like you were doing before. You have to find the values of x, but the interior angles here equal 360 degrees. Therefore, this is 100, and that's 260. So this has to be equal to 100 degrees. And then you would define this as a trapezoid and a quadrilateral. Finally, the last one here, this appears, we got opposite angles are equal to each other. Opposite angles have to be equal to each other. So this is 140. So these two angles have to add up to 220 degrees, but they have to be equal. So this has to be 110. Whoops. And this has to be 110 degrees. And then, because we don't know the sides, this one's tough, so we would just call it a quadrilateral. Okay? I know that's a lot of information, but make sure you ask me questions, and we'll work on more of these in class.